Okay, so this bit's tricky because you never got a chance to actually get taught this. I've taught it briefly in terms of getting you ready for your mock. And of course, I will teach it again properly later. But what have I said to you so far? In the history of time, no one has ever died going quickly. 0 people. They've all died stopping quickly. And the crucial part is, well, we've got this idea of momentum. And it's just a measure of how difficult it is to stop moving objects. So if I quickly go onto the side here, you're going to see that you've got these 2 formulas that are linked together. And again, these come from Newton's law of motion. So we've got magic, there's momentum there, puking vampire, and then we've got frogs, puke, tarantulas. And at a higher tier, you'll tend to need to, if I just change my colour, nice little green there, you'll tend to need to do this bit first, which is work out the momentum, and then use that to work out a force at a higher tier. And I've always said to you, multi-step are the more difficult ones, because you've got to keep a handle on, work out this to then use that to work something out. So our first part is, what's the momentum? Magic, puking, vampire. Momentum is delta P. So we know delta P equals mv. This is in grams. I want it in kilograms. Divide 1,000 equals 0.4 kilograms. And that's perfect. That's exactly what I want. And then I'm ready to go. So that's just going to equal 0.4 times 18 equals 7.2. Now the units, if I just get rid of that there, this is in kilograms. This is in meters per second. And just like in maths, where you have A times B equals AB, well, these units will just sit next to each other. So the unit is kilogram meters per second. One of the nicer units to use. Okay, so we've got the next one, which is just got to use the same formula, except for I've got to rearrange it now for M. So magic, puking, vampire. I want M. Previously, you had to work out that. M equals delta P over V. Perfect, you're exactly as I want it to be. Perfect, you're as I want it to be. So now I can say I just got to pull down the momentum, 1,200 divided by 24. Put it into my calculator now. Equals 50, and the unit for mass is kilograms. Mark, mark, mark. And then the next part is a really tricky question. So it says, what's the maximum force experienced by a 2-ton truck moving at 22 meters per second if it comes to a stop in 400 milliseconds? So this is really nasty. This is that example where I've got to use, and I'll just move this onto the side there, magic, puking, vampire to work out that. Once I've got that, I use that into frogs, puke, tarantulas. And that's F, so a bit ropey. Let's go with that there. So now I'm ready to go. So just remember, do you first, do you second. So 2 tons, that's 2,000 kilograms, 22 meters per second, happy with that. 400 milliseconds, milli divide 1,000. If you're always used to kilo times 1,000, milli divide 1,000, that'll take you a long way on any of these. So 400 divided by 1,000 equals 0.4 seconds. And now I'm ready to go. So I'll go through the steps. I'm going to change my colour now, actually. Let's go with, that seems quite nice. So step 1. Magic, puking, vampire. Work out the momentum. Delta P equals mv. Delta P equals the mass. 2,000 times the velocity. 22. Put into my calculator. Equals 44,000. And now the unit, well, it's kilograms times meters per second. So that's kilogram meters per second. I'm circling you. I need to use you in the next step. So my next step, frogs, puke, tarantulas. And now I want to work out the force. F equals delta P over T. That's going to equal what I worked out. That's why it's higher tier. Divided by the time, 0.4. So the force equals 110,000, and the unit for force is newtons. So really tricky question there. And hopefully you just got this idea. Momentum is a measure of how difficult it is to stop moving objects. and it's the mass times the velocity. If you ever want to work out the force, it's whatever the momentum is divided by the time. And that's because the force is a lot higher the shorter the time. Okay, no one has ever died going quick. They've all died stopping quickly.